Alright, Algebra Chapter 6 review. We're getting ready to test. Okay, I'm going to go over a few of these and explain some of them. I'm not going to work them all out step by step, but just a couple of pointers here. So here, I've been asked whether we can simplify 12 and 3. Remember, you have to do exponents before you do multiplication and division. So we need to move this up. Okay, we're going to move this up. And move this up, making all those positive, and move this one down. Alright, so that gives us this expression here. Now, y to the third times y to the fourth gives me y to the seventh. 12 times 3 squared, 12 times 9 is 108. And x to the second over x to the fifth. There are two x's on top, 5 on bottom. You can cancel out 2, top and bottom, leaving you with 3 in the denominator. Okay, here there's a couple different approaches. Either you can first take this exponent and apply it to each factor. So then we get 5 to the negative third, x to the negative 12th, and then we can flip that to the other side of the fraction, bring those down, get this expression down here basically, and end up with that answer. Remember, y to the 0 power is 1, so that's why that's not here. I could write times 1. Or I can first say this is over 1, and then apply the negative, flip it, and make that positive. Now when I flip it, notice none of the exponents change. Everything stays exactly the same, except we flip it upside down to get rid of that negative. And then I can apply that exponent to all these exponents. Remember, the 5 has an imaginary 1 there. 1 times 3 is 3, 4 times 3 is 12, 0 times 3 is still 0. And that's how I get that answer. Alright, I'm going to cruise through some of these. You can have a look at these two different methods of how to solve it. Either apply the exponent first or flip it first. Okay, this one a lot of you had trouble with. What does it mean to write it as a power of a product? So usually you've seen this, and they said simplify, so that means multiply all the exponents with it. Well, they want you to go from this expression the other way around, so from this expression to this. So you have to look at the 9, see, okay, I can rewrite that as 3 squared. And then all these exponents have a factor of 2, so I can take that factor out, and I get this expression. Same thing in number 5. Okay, number 6, first thing, I'll rewrite this. That's a cube root, and then to the negative second power. It doesn't matter whether that's down here or out there. So I can first do the cube root and then do the negative second power, or first negative second power and then cube root. So I'm going to first cube root it, because that's easier, and that's 3. And then to the negative second is 1 over 3 squared, which is 1 over 9. Okay, 7 doesn't need a lot of explanation. 8, same situation. I can put the square underneath or outside. So I put it outside because I know the cube root of 8 is 2, and 2 squared is 4. Here I have a negative 1, so again I did the cube root of 27, and then flipped it, and then I get 4/3. Okay, number 9, I know some of you were struggling with. So I have factored this one out. Okay, negative 250. What factor gives me negative 250? I could have either done negative 2 times 5 times 5 times 5, or notice I have negative 5 times negative 5 times negative 5. This right here is a cube. 3 equal factors. So I can pull that out. The cube root of that is 1 of its 3 equal factors, so negative 5. Here is another cube, 3 equal factors, so I get an x. There's another cube right here, so I get a y. And then there's another cube right there, so another y. And then everything else stays under that cube root, 2x. And 2 y's, y times y. And then we'd rewrite that negative 5x y squared, cube root of 2xy squared. Number 10, split this up into 12a cubed over square root of 36. And that gives me 6 down here. Now I've rationalized the denominator. Very nice. 12 is 2 radical 3 because 4 times 3, square root of 4 is 2. And then a to the third, I can pull 1a out because that's a squared times a, so I get 2a, and then here's an a, simplify the 2 and the 6, get 3 there, 1 here, and that's how I get a times 3 radical a over 3. Similar here, you can either simplify first or split this up, 50 y to the 6th over 100 x to the 4th. Now if we're working with square roots and variables, 100 square root of 100 is 10. Square root of x to the 4th is x squared. 50 is 25 times 2. Square root of 25 is 5. And the 2 stays under there. Square root of y to the 6th is y to the 3rd. And then we can simplify here 1 and 2. So y to the 3rd radical 2 over 2x squared. When we want to rationalize the denominator and all you have here is a product, we can multiply by that radical. That would give me negative 7 radical 3 over 2 times 3. Because remember, when you multiply these together, that squares it and cancels out the radical. So that's negative 7 radical 3 over 6. If you have a sum or a difference, you have to use a conjugate, because then you get the first term squared minus the second term squared. Okay, so in this case a is radical x, so I'll write this out so you can see what we have here. First term minus the second term is x squared. And then on top, distributive property, 3 radical x minus 3x. And here, the square and the radical cancel out. Then you have 3 radical x minus 3x over x minus x squared. Okay, this one I've broken down for you. You can see here I've split this up so you can see we have a square root and there's a square. I can pull that out. That's a 2. Here's another square, so I can pull that out. X, 2 times x. And in this one I have a 3 underneath there because 45 is 9 times 5. That's 3 times 3. So there we go. And that's simplified. Graphing the function, make yourself a table and then plug in. So if I plug in 0 here, that's pretty easy. That's 1, so I get negative 1/2. Negative 1/2. So I can graph that. 0, x is 0. We're at negative 1/2. We're going by 2's here, so that's 1. So we'd be right around there. Plug in 1 there. 4 times negative 1/2 is negative 2. So at 1, we are at negative 2. And then plug in 2. 4 squared times 1/2 is 8, so that's negative 8. Negative 8. Now I can keep going this way, but I know what's happening from here to here, right? Notice it's always times 4, because that's the ratio. So times 4, I can do negative 8 times 4. And negative, well, 32 is not on the graph anymore. All right, at 3, I'd be way down here. And then negative 1. I can either put that in here, negative 1, make that a fraction, 1/2 times 1/4, and get negative 1/8, or I could have just divided by 4 going the other way. So negative 1/8, which would be somewhere here. Notice it's getting closer to this line. I would be at negative 1/16, and so on. So then to graph it, and exponential, woo, down there. Okay. Same procedure for number 16. And here, determine whether they're arithmetic, geometric, or neither. We want to see, is there a common difference or is there a common ratio? Here we're adding, but we're adding 2, then we're adding 3, then we're adding 4. We're not doing times 2 or times 3 or anything like that. So this is neither. Here, every time we're multiplying by a negative a half. So that's geometric. Here, I converted this. When you're working with fractions, it's easier to see if you have common denominator. So I can convert it to common denominators. From 4/6 to 1/6 to -2, we're subtracting 3/6. Now I realize that's a half, but it's easier to think of when you have sixths. So that is arithmetic. And then here, times 2, geometric. There you have it. Oh, then one more. Okay, here you go. Plug this in, shiggity schwa, and boom. Alright, same thing here. Plug in, have fun. An exponent of a half means square root. There you go. Alright, and good luck on that test.